Good morning, everybody. This is Ganesh. So now I can start our session now. Okay, in the last class, we are practice with some SQL queries. So if we are having the time, so we will try to practice in another session also. Okay, so now we'll try to discuss about the transaction management. Okay, I hope my voice is audible to everyone. Is it right or not? So now I try to share my screen. So please try to check once whether my screen is visible to you or not. So may I continue my session now? May I continue my session? Please respond anyone through chat box. Is it my voice is audible? Are you able to see the screen? May I continue my session? Please respond anyone through chat box. Yeah, thank you. Thank you. Enough. Okay, in the last classes, we are discussing about transaction management. Okay, so now today we try to just revise those concepts now. Okay, at any cost, we will try to complete the syllabus up, within this month, no doubt at all. Okay, so if you having any type of the doubts, you can contact me personally also. Okay, I will try to issue the assignment, so maybe tomorrow. Okay, so you can submit that assignment within that week also. Okay, so in the last classes we are discussing about the transaction management. So we're already discussing about this. What is the transaction? What is the transaction management, and what are the transaction management properties? So all these topics are we are already discussed in the last classes, and which type of operations are we are perform, how do we are performing the operations, and what are the examples for the atmospheric consistency, isolation, durability. Am I right? So I think these topics are need not necessary to repeat again. Okay, and we are already discussing about the states of the transaction also. So transaction is also a nothing but like as a process. Okay, so what is a process? Actually, the execution of the program will be referred as a process. In the same way, here the transaction is nothing but a set of actions. Okay, if all the actions are successfully completed, then only the transaction only completed. Okay, so then only the transaction committed to the disk. Okay, so what are the states of the transaction? Okay, so for example, when we are based upon to the transaction database management system to performing the operations. So at the demo the situation, we need to based upon the transactions only. Okay, for example, if we are going to the bank, so we are depositing some amount into the bank. Okay, so at the demo situation, so that will be identified by transaction. Okay, so it will be identified by a transaction. Okay, so another thing here, what are the states of the transaction? So whenever one transaction is ready to execute, so it starts its execution, so that is in active state. Okay, so whenever it is executed, some of the instructions, some of the actions in a transaction, so that is in partial committed state. Okay, so and next one, if the transaction is successfully completed, so that means if all the actions of the transaction is successfully executed by the database management system, so that will be in the state of committed state. What is the meaning of committed? So commit means, so we're already using the commit, am right? So we're already using three types of commands in the transaction control language. Okay, so what are they? So rollback, save point, and another one is the commit. So what is the meaning of commit actually here? Uh, what is the meaning of commit? So that means whatever we are performing the changes, those are written to the disk. So once it is written to the disk, we can retrieve any number of times. Okay, so that is the main purpose of using the commit. For example, during the execution of the transaction, if any one of the action is not completed, so it will be leads to the failure state, and finally it will be aborted by the Dbms, and it will be automatically starts by Dbms, and it will be considered as a new transaction. We already know about this. We are already discussing about this. Just to try to revise this concept. Why? Because in the exam point of view, this is also maybe asking some type of situations. So that's why I'm asking. That's why I try to repeat this session now. Okay. And another thing. Okay, so these are the explanation about this transaction. So I will try to send this material. I will try to share this. Okay. Uh, okay. Thank you. So another thing is the main thing is transactions and schedules. Okay, transactions and schedules. A transaction is seen by the DBMS a series of or list of actions. So that means a list of actions will be referred as a transaction. So the actions that can be executed with the transaction include reads or writes of the database objects. So that means, so which type of operations are we are performed onto the data items? So those are either read operation or maybe the write operation. So what is the meaning of read operation? Read operation means nothing but we are retrieving the data. Write operation means nothing but we are performing some changes on the data. So here we are using some schedule also. What is the meaning of schedule? So which type of order used for to executing the transaction will be specified by using schedule. So here we are considered the three types of schedules. So that is also we are discussed in the last classes. I'm right. So that is nothing but serial schedule. Another one is the non-serial schedule. Another one is the serializable schedule. So we're already discussing about this. Just to try to revise once again. Okay. So what is the meaning of serial schedule? I think the name is in place. So here, after execution of one transaction, then starts the execution of another transaction. So if this order is followed, so there is nothing but a serial schedule. Okay. If you observe here the example, so in this chapter, you try to represent some examples like this. So these are having the better understanding. So in the point of exam point of view also, okay, so this is the best way to representing the answers. In the previous class also I am saying about that. So when you are representing your answer, so better you try to represent with some diagram or table, okay, some pictorial representation or some neat representation, some neat handwriting. Okay, so these are the uh, best way to present our topic, and the evaluator also impress within the 3 minutes to correct your paper. Okay, and you will have the chance to get good marks if you are representing like this. So whatever it may be the concept, just better you try to give the some example. Okay, so for example, if you are observing here, so here this is the serial schedule. Okay, so what is the serial schedule definition? So schedule means nothing but selecting which transaction is executed in that particular time, or deciding the order. So which type of order we are executing the transaction. So that is nothing but a schedule. So in the case of serial schedule, so after execution of one transaction starts the execution of another transaction. If you observe here, two transactions there. So T1 having read anu and write anu and read read and write read. So those are the actions of the transaction of T1. So then the same actions of the transaction T2 will be executing here. Okay, so that means after the completion of T1 only starts the execution of T2. So in the case of process scheduling also, we are using this. Am I right? So preemptive scheduling and non-preemptive scheduling. So what is the meaning of preemptive scheduling? Before the completion of one process execution starts the execution of another process. So that is nothing but a preemptive. I think the name is in place. Their preemption. So nothing but giving the chance. This is the example for non-preemptive scheduling. So what is the meaning of non-preemptive scheduling? So after the completion of one process execution only starts the execution of another process. In the same way, here also, in the case of serial schedule, here starts the execution of transaction. So after the completion of one transaction only starts the execution of another transaction. So non-serial schedule, I think the name is in place, and this is the reverse for to the serial schedule. Okay, so that means before the completion of one transaction execution starts the execution of another transaction. So nothing but this type of process will be referred as a context switching also. Okay, for example, if you observe here, T1 starts the read operation on Anu. In the same way, T2 also starts the operation of read Anu and write Anu and read read. So here, if you observe here, again, the T1 will be takes the position and starts the execution. So that means here, this type of execution will be referred as a interleaved execution. In the last class, we are already discussing about the which type of problems are occurred when we are considered the interleaved execution. Am I right? Okay, so if for example, if the execution is in this order, so that means, so for example, if the question is like this, so what is a schedule? What are the types of schedules? in your transaction management. Then you need to explain first of all what is the transaction, what is the transaction management, what is schedule, what are the types of schedules, and give the example in this manner. Okay, and you try to explain that example. Okay, so next one is the concurrent execution of transaction. I hope all of the members able to understood this. So if it is a serial schedule means nothing but after the completion of one transaction execution only starts the execution of another transaction. Okay, serial, the name is implies serial, one by one. Okay, so if it is a non-serial schedule, so before completion of one transaction execution starts the execution of another transaction. So at this time of situation we need to maintain some nothing but we need to maintain some security, otherwise maybe occurring the problems. So here security means nothing but verifying which type of operation it is. So before performing the execution on the particular data item by the transaction, first of all verify whether it is a read operation or maybe the write operation. So if it is a read operation, there is no problem. Why? Because here we are only retrieving the data, we are not changing the data. Okay, just only we are retrieving the information from the database. But in the case of write operation, so we need to maintain some care about that particular transaction. Why? Because so during the execution of transaction, maybe some other transaction may be performing some other operation. At that time of the situation occurring the problems. In the last class also we are discussing about that. Right? So just we are discussing about two types of schedule. One is the serial schedule and another one is the non-serial schedule. Then what is the serializability schedule? Okay, what is the serializability schedule? So don't try to get confused. In the previous case I mentioned about serial schedule and non-serial schedule. Okay, serial means one by one, non-serial means need not wait for one transaction execution for another transaction. Okay, so then what is the serializability means nothing but, for example, if you are executing some transactions, so those are executed in the serial schedule, and the same transactions with the same data items executed in the non-serial schedule also. Okay, so if these two schedules producing the same result, so that is nothing but a property of serializability. So then so we can clearly say these two transactions maintain the property about serializability. In some type of situations occurring the problem of conflict serializability, so then we need to maintain the serializability. In the exam point of view also asking about this question in some type of situation, some type of situations, maybe how we are able to identify whether the transactions executed in the serializability or not, or maybe what is the conflict serializability. So like this. Okay, so we'll try to discuss about that. So just to try to revise again, so what is the meaning of concurrent execution of transactions? So that means whenever more than one transaction is executed at a time. Okay, so that type of the transactions are will be referred as a concurrent execution of transactions. So that means more than one transaction is able to perform at a time on the single data item or single shared data item. So the type of the execution of the transactions will be referred as a concurrent execution of transactions. So the best example is railway reservation. Okay, so for example, nowadays actually railway reservation is uh, some more complicated, but in the previous days, in the case of this, just wait. This just wait. Okay. Okay, the best example for the concurrent execution of the transaction is railway reservation. Why? Because at a time, more than one user operated under the same shared data item. Okay, same type of the database. So more than one user operated at a time on a single data item. For example, the same train will be reserved by more than one user at a time on the same date, on the same time, on the same place. So maybe the chance. So at the time of the situation here occurring the problem. So that means here generally we are allowing that to performing the operation about right operation. I'm right. So it is a right operation. So at the time of the situation here here occurring the problem. So at the time of the situation, one of the, so only one of the user will be allowed to perform the right operation. Then remaining users will be performing the in the waiting state. So that's why maybe so it will be, maybe we will be seeing on the screen that is the buffering. So what it means, so some of the user operating on the same data item on the same data on the same data. Okay, so this is the best example for concurrent execution of transactions. Even though we are allowing more number of users at a time to performing the operations on the same shared data item, so we need to maintain the security without occurring the chance of losing the data. Okay, so that is the main goal of database management system. Okay, the DBMS centralizes the execution of different transactions to improve the performance in terms of increased throughput or improve response time, short transactions, but not all interleaving should be allowed. So that means, so concurrent execution of transactions means nothing but here we are consider only interleaved schedule. So why? Because in the case of interleaved schedule only, we are able to allow more than one transaction at a time. But in the case of serial schedule, we are not able to allow more than one transaction at a time. Okay. So next, what is the advantage of concurrent execution of transactions? So one of the main advantages is nothing but improved throughput. Okay, so one of the best advantage is improved the throughput. Okay, so nothing but what is the meaning of throughput? How many number of outputs are generated within the time. Okay, so for example, maybe so in this year, so in particular subject, how many number of students are passed in the exam. In the same way, so we count the same thing in the next year in the same subject, how many number of students are passed in that particular exam, or maybe how many number of students are at a time completing all subjects. Okay, so maybe if the duration is the same, so nothing but how many number of outputs are generated within the particular amount of time, that will be referred to as a throughput. Okay, so that means here we are verifying number of outputs. Okay, so improving throughput, and another one is the reducing the wait time. So for example, when we are allowing more than one transaction at a time to perform the on the operation on the same data item, so then if any type of the situation may be occurring the problem, so then so here CPU is not performing the waiting operation, so that will be assigned for to the execution for another one. So in the case of computer organization subject, so we are discussing about that like as an interrupt also. So what is the interrupt actually? Interrupt is a nothing but suspend the current execution of the CPU and transfer the control to the interrupt service routine. After the completion of the interrupt service routine, then again the control back to the same position. So that is the definition of interrupt. We also know about that. Okay. So now we try to see the what is the serializability. So in the previous case, I'm already saying about that. For example, if you observe here, so whenever the serial schedule and non-serial schedule produce the same result with the same type of transactions with the same data items, so that will be referred as a serializability. So then these two transactions maintains the serializability. If you observe here, read x, write x, read y, write y. Next starts the execution of T2, read x, write x, read y, write y. So this is the serial schedule. So that is the first diagram. Okay. So if we are observing here non-serial schedule or maybe the interlude schedule, read x, write x. Again, T2 will be perform the same operation. Read y, write y by the T1 and read y, write y by the T2. So that means the result is same. So that means these two. So if you are observing here on the screen, the above two schedules produce the same result. These schedules are said to be serializable. So that means if the result of serial schedule and non-serial schedule producing the same result with the same type of transactions with the same data item, so that will be referred as a serializability. Okay, the transaction may be interleaved if any order of the DBMS doesn't provide the guarantee about that order in which they are executed. So here we are consider the two types of serializabilities. Okay, so what are they? So one is the conflict serializability, another one is the view serializability. I think the name is implies. In the case of conflict serializability, occurring the problem. Okay, in the case of view serializability, we try to maintain the serializability. So that means here we try to verify in which type of they starts the execution of uh, transactions. Okay, now we try to see what is a conflict serializability. Okay, any given current concurrent schedule is said to be conflict serializable if and only if conflict equivalent to one of the possible serial schedule. So consider schedule S1 consisting of two successive instructions IA and IB. So that means here we are consider one schedule. The schedule name is S1 and consists of here two instructions IA and IB. Okay, So next transaction TA and TB, two different data items, then it is very easy to swap these instructions. The result of swapping these instructions doesn't have any impact on the remaining instructions in the schedule. If IA and IB are referred to the same data item in the following cases, just to try to observe here. So that means here we are consider the two transactions. What are they? TA and TB. Okay, and here we are consider the two instructions. What are they? IA and IB. Okay, so case one, if you observe here, so IA equal to read of X, IB equal to read of X. So actually there is no problem. Why? Because both are performing the read operation, right? So here producing the result is also same. Okay, but if we are observing the case 2, IA equal to read X and IB equal to write of X. So that means here also not occurring the problem if the order is IA to IB. So that means after the completion of IA, so then starts the execution of IB, then there is no problem. But if the order is IB to IA, okay, so then occurring the problem. Okay, just to try to see in the screen first of all. So here we are consider the two same data item. Okay, but consider the two instructions. At the same time consider the two transactions. Okay, don't try to get confused. So TA and TB are the transactions, IA and IB are the instructions. Only the single shared data item is X. Okay, so just to try to observe the case one now. So IA performing the read operation and IB performing the read operation. Okay, here both, just to try to observe on the screen case one. Okay, here both IA and IB are the read instructions. In this case, the execution order of the instructions is not considered, since the same data item X is read by the both transactions T and TB. So there is no problem. Why? Because it is a read operation. Am right? So actually this is the problem. So when we are allowing more than one transaction at a time to performing the same operation on the same data item, then occurring the problem here. So then we need to verify the order also. So otherwise occurring the problem of conflict serializability. Second one. So here, what is the second one? So IA performing the read operation, IB performing the write operation. So now here, IA and IB are the read and write instructions respectively. Okay, if the execution order is IA to IB, what it means? What is the operation of IA? Read operation. What is the operation of IB? Write operation. So that means after read, if we are performing the changes, there is no problem. Am right or not? So if you are performing any type of the changes after reading the data, there is no problem actually. Okay, uh, but if you are performing the okay, just wait, just you try to see. If the execution order of the instruction is IA to IB, then the transaction TA cannot read the value of written by a transaction TB instruction IB. So that means, for example, here, what is the operation of IA? Read operation. What is the operation of IB? Write operation. So IA is executed by TA and IB is executed by TB. So, but this operation is not performed. Why? Because these are parallelly executed. So that means TA cannot read the value written by a transaction TB in the instruction IB. So that means actually the same data item is read by one transaction. The same data item is write by another transaction. So that is the problem. But the order of instructions IB to IA. So that means after performing the write operation, we are reading the data, then there is no problem. Okay, so for example, but the order is IB to IA, then the transaction TA can read the value written by transaction by TB. So therefore, in this case, the execution of order of the instruction is important. Okay, I hope all of the members able to understood this. So that means if we are performing some changes at the demo situation, we need not to performing the read operation. I'm right. For example, so I just try to change the value now of the one variable. So during the I'm performing the write operation, if anyone is read the value, then definitely he will get some error. Am right or not? So that means he receives error value. So for example, maybe I'm changing the value of a, actually a value equals to 5, but I'm changing that value a equals to 50. Okay, for example, during my write operation, if any one of the person is try to perform the read operation, then which type of value he received? Actually a equal to 5, but here what is the value of actual value of a? 50. Right or not? So during the write operation, we should not perform to the read operation. If you are performing the read operation on that time, so definitely we will get error result or error value. Okay, so for example, maybe I'm changing the a value equals to 50. Then some person wants to perform the read operation. Then what he value gets the value of a equal to 50. There is no problem. So that means after the write operation only we will be able to read the value of that data item. So here also the same thing is maintained. So the order is IB to IA. Then TB cannot read the value of written by transaction TB. So therefore, in this case, the execution of order of instructions is important. Okay. Okay. Now try to see the case 3. What is the case 3? IA equal to write of X and IB equal to read of X. So that means IA is executed by TA and IB is executed by the TB. So transaction TA performing write operation on the data item of X. Then read operation on performed by to the same X by the IB in TB. Okay. So for example, if the here if you just try to see in the screen, IA and IB are the read and write instructions respectively. If the execution order of the instructions IA to IB, then the transaction TB can read the value written by transaction DA. Okay, so that means here, so here what is the meaning of arrow means? So first executes the IA. Okay, what is the value? What is the operation of IA? Performing the write operation on X. Okay, for example, if the execution order of the instructions is IA to IB, then transaction TB can read the value of written by transaction TA. So that means after performing the write operation, we can read the data item. There is no problem. But if the order is IB to IA, then we can't read the value written by the transaction by TB. So therefore, in this case also execution of the order of the instructions is important. So now consider the last case. So first transaction will be performing the write operation on the same data item. At the same time, second transaction is also performing the write operation on the same data item. So here we need to consider this. So here both I and IB are the right instructions. In this case, the execution order of the instruction doesn't matter. If a read operation is performed before the write operation, then the data item which was already stored in the database is read. So that means here, so for example, first of all, one transaction performing the write operation on the some data item. Then next, another transaction performing the write operation on the same data item. So then here we need to verify so in which type of they are executed. Okay, so here also we need to here we need not to consider the order. So but we try to mention so we try to focus in which type of they are executed. Okay, so two instructions I and IB are said to be conflict if and only if they represent the operation performed by two different transactions on the same data item. So for example, so here we are considered two transactions I and IB are conflict. So how we can say that? So they represent the operations performed by two different transactions on the same data item. So that means when we are based upon the same data item, but performed by the more than one transaction, at least one among I and IB is write operation. Let us consider the following schedule S2. Okay, here write of X operation of T1 conflicts with the read of X operation of T2. But the write of X operation of T2 doesn't conflict with the read of Y operation of T2. So since these instructions perform their operations on two different data items. So for example, if you observe here, so transaction T1 performs the read operation on the X data item, and transaction T2 performs the read operation on X data item. Okay, please just wait. I will just call you. Okay, I hope my voice is audible to everyone. Is it right? Yeah. Please just wait. Yeah. Okay, if you're observe here, one of the transaction performing the read-X and write-X, and next T2 performing the read-X and write-X, and next T1 performs the read-Y and write-Y, and T2 performs the read-Y and write-Y. So actually, so this is a not a problem. So this type of execution is executed so without any problems. Okay, now try to see conflict equivalent. So the order of the instructions I and IB can be swapped when I and IB belonging to the two different transactions. I and IB are not conflicting instructions. Okay, so that means what is the meaning of conflict equivalent here? So the order of the instructions of I and IB can be swapped. So here we can able to swap I and IB. Okay, so for example, if these two are belonging to the two different transactions and these two are not having any type of the conflicts, then only we are able to swap between these instructions. The execution order of the instruction schedule S2 are swapped so as to generate new schedule S2 dash, which is equivalent to S2. S2 is said to be equivalent to S2 dash because the order of executing instructions S2 dash is similar to the execution of order in S2, except for the instructions I and IB. So that means here just you don't try to get confused. Here just to try to change the order of the instructions executions only. So for example, if any type of the conflicts are there, we need not to perform any type of the swap. So if any chances are there, so we can try to perform the swapping. Okay. So even though we are performing the swap, any type of the changes are not occur. So that is nothing but equivalent to the conflict equivalent. Okay. I hope all of the members are able to understood this. Okay, if you observe here, so this is the nothing but schedule S2 dash. So if you observe here, so actually this is the S2, am right? So in which type of we are performing the operations? Read X, write X, next read Y, write Y by the T1. But this is the interleaved schedule, am right? So in the case of T2 also read X, write X, and read Y, write Y. But the same S2 will be we can convert it to the like this. If any type of the problems are not there, so that will be referred as a conflict equivalent. So since the schedule S2 is equivalent to the schedule S2 dash, so therefore S2 and S2 dash are said to be conflict equivalent. I hope all of the members able to understood this. Okay, the conflict equivalence leads to another notion called conflict serializability. Okay, so I hope all of the members able to understood this. Okay, so even though we are performing some swapping between the instructions, so if they are belonging to the performing the operation under the same data item, so then if there is no conflicts between them, so then the type of the thing will be referred as a conflict equivalent. Okay, uh, okay, next we try to discuss about the view serializability. Okay, any given concurrent schedule is said to be view serializable if and only if it is view equivalent to the one of the possible serial schedule. Okay, so just we try to see here also we try to verify the execution of transactions. So here also we need to perform some changes. So then also, so whether it is able to maintain the same type of results or not. So that means what is the meaning of serializability? So first, just I try to repeat now. So what is the meaning of serial schedule? Serial schedule means after execution of one transaction starts the execution of another transaction. Am I right? That is nothing but a serial schedule. Okay. So what is the meaning of non-serial schedule? So during the execution of one transaction execution starts the execution of another transaction execution. So nothing but that is nothing but non-serial schedule. So then what is the serializability? If these two schedules, so serializable schedule and non-serializable schedule, so consider the same data item, if they are producing the same result, that is nothing but a serializability. Okay, so then what is a conflict serializability? In some type of situations we need to maintain so we need to verify the order of execution of instructions, otherwise occurring the conflict serializability. Okay, then what is a conflict equivalent? So what is the meaning of conflict equivalent? Means nothing but here, even though we are performing some changes or maybe some swapping between the instructions within the schedules, Okay, there is no for example, even though we are performing some swapping between the instructions, then also not occurring any type of the problems, that is nothing but conflict equivalent. Now we try to discuss about the view serializability. So that means we need to verify the whether those type of transactions, those within the those type of schedules, so produce the same result or not. So we need to verify the order also. Okay, just to try to see now, any given concurrent schedule is said to be view serializable if and only if it is view equivalent to the one of the possible serial schedule. Okay, two schedules S1 and S1 dash consisting of some set of transactions are said to be view equivalent if the following conditions are satisfied. Okay, if transaction TA is in schedule S1, performs read operation on the initial value of the data item X, and then same transaction in schedule S1 dash must also perform the read operation on the initial value of the X. So then, so there is no problem. I'm right. So if a transaction of TA S1, okay, TA in schedule S1 performs the read operation on the initial value of data item of X, and the same transaction in the schedule S1 dash must also perform the read operation on the initial value of the X. So that means here we have considered the two transactions, S1 and S1 dash. Okay. So, but both are performing the read operation on the single data item. There is no problem. So if a transaction TA schedule S1 reads the value of X, which was written by the transaction by TB, okay, then TA in schedule S1 dash must also perform the read the value of X written by the transaction TB. So in this case, here occurring the problem. So here we need to verify the execution of the transactions. Okay, so these type of whether these type of transactions executions producing any type of the conflicts or not. If any conflicts are not there, so that is nothing but a view serializability. Okay, so in the last class we are discussing about the anomalies due to the interleaved execution, right? So this is very important question in the exam point of view also. This is maybe asking number of times. Okay, today just only we are discussing about what is a schedule, okay, what is a serial schedule, what is a non-serial schedule, what is a serializability, what is a conflict serializability, what is conflict equivalent, and what is view serializability. Okay, so now try to discuss, just revise once, anomalies due to interleaved execution. So that means what a anomalous means nothing but it is a error. So when we are consider the interleaved execution occurring some problems. Okay, so what are they? So here basically we are consider the three types of problems. What are they? Write read conflict, read write conflict, write write conflict. Okay, so write read conflict means nothing but just divide W R. Okay, W belongs to the T1 and R belongs to the T2. So that means T1 performing the write operation and T2 performing the read operation. Okay, so if you are allowed to executing the transactions in this same manner without performing the commit, then also occurring the problem. So actually these three operations are conflicts. Okay, in the last class we are already discussing about this. Okay, so we'll try to discuss about the remaining topics in the next class. Okay, so if you are having any type of the doubts, you can ask me now. So otherwise I will end the session today. So if I'm having the chance, next class I will try to explain through the system with the execution of SQL. So actually there is no need. So we need to complete first 16 it. Okay. So just if I'm having the chance in the next class, definitely I will continue with the system to explain some more comments. So in the last class also, just to try to revise the comments, DDL comments, DML comments, and but we are not using the DCL and TCL. So if I'm having the chance in the next class, definitely I will continue with the DCL and TCL also. So you try to remember all those comments. Why? Because so those are user for to elaborate the answer. For example, now we are in the transaction management. TCL comments are very useful. What are the commit, rollback, and save point? So you need to include that. So then it will be giving the some efficient answer. Okay. If you're having any type of the problems, you can try to ask with me now. So I will give you the chance to perform the unmute for you. So if any member may end my session. Okay, thank you, Ananda. Take care, all of you. Have a nice day.